Okay, so we're going to do now simplifying monomials. Remember, you have to do part A with me now. We're going to go over it together. When I look at your relearn packet, there better be work shown. It better all be written down there. Then you're going to do part B on your own. When you're done with part B, you got to bring it to a qualified person, and that does mean someone excellent at math. You can see me during lunch. You can see me during extra help. And then once we know you're doing part B correctly, then you can go forward and do part C. Okay, so part A on the video, Mr. L will do these questions. Here we go. Number one is like from section 2. But I want to make sure we just review the point. Whenever you add or subtract anything on the face of the earth, you always get back the same kind of thing that you started with. So, this is negative 4x's, and this is negative 3x's. If I have negative 4x's and negative 3x's, what do I get when I add them up? No, you get negative 7x. Now the good news is you knew that the x's stayed the same, because whenever you add or subtract, you don't change exponents. They always stay the same kind of thing. But if I have 4 negatives and I have 3 more negatives, what do I have altogether? I have 7 negatives. Okay, so it should be negative 7x. Now, if you notice, that's actually like section 2 that you'll watch the video for if you need to. And the important thing to realize in section 2 we're always adding or subtracting, and the exponents stay the same. I started with an x, I added an x, and I came out with an x. Kind of like if you go shopping. If you buy shirts, and you buy more shirts, and you get home and you look in the bag, they don't suddenly change to shoes, do they? They stay shirts. All right. However, when I start dealing with multiplying and dividing and exponentiation, then the exponents can change. And you have to remember that there are basically 3 rules. One rule says that x to the a times x to the b is x to the a plus b. And I know that looks fancy, but all you got to realize is when you're multiplying, common base, just add the exponents. Another one was, if I do x to the a over x to the b, if I'm dividing common base, I subtract the exponents. And then when I raise a power to a power, I multiply. Everything kind of takes a step down in terms of the level of operations. When I multiply, I add exponents. When I divide, I subtract exponents. Adding is like simplified multiplication. Subtraction is like simplified division. And multiplying is like simplified exponentiation. So if I multiply, I add exponents. If I divide, I subtract exponents. If I raise a power to a power, I multiply exponents. So number 2, if I call this case A, case B, and case C, look at number 2 up on the board there. What case is that? Is that like case A, case B, or case C? Michael? Case C. Sure. And when we raise a power to a power, what do I do with those things? Ms. Savino? Multiply, good. So if I have f to the 2nd to the 5th, what do I get all together? Everybody. F to the 10th, good. Okay. Now, if you notice, number 2 and number 3 are very similar, but there is something a little different. Cassandra, what's different about number 3 compared to number 2? What's different about number 3 here compared to number 2 here? Yeah, that's right. Right, there's a number inside the parentheses too. So not only do I have to raise the f squared to the 3rd power, but I also have to raise the 2 to the 3rd power. So 2 to the 3rd power means 2 times 2 times 2. What is 2 to the 3rd power? 8 it is, good. And then when I raise a power to a power, I multiply f to the 6th. So that is case C. All right. What kind of questions raise powers to powers? Now, let's take a look at number 4. Is number 4 like the 3rd case? No, what case is it like? Michael? Case A. I'm just multiplying the common base. In this case, the common base is x to the 3rd. So we said this many, many times leading up to the test. You're going to multiply coefficients, add exponents. So the what is a coefficient again? Good, the number in front. So what's negative 3 times negative 5? Positive 15, good. You know that because when you multiply by a negative, which this is, I have to change the first sign. So I get 15, and then x to the third times x to the second is x to the fifth. Good. Nicely done. Way to be all over that, Jennifer. Well, the Jennifer was also answering right behind you. Okay, next. Again, same idea. Let's multiply coefficients, and let's add exponents. So what are the coefficients in this problem? Jen, what do you got? 2 and 5. Good. So when you multiply them, you get? Nice. Then what do I do to the exponents? Add them. Now, on the test, I did notice some kids messed up because they forgot that that's a 1. When you don't write an exponent, there's really a little 1 there. So on the test, some people wrote something like 10a squared, but it should not be 10a squared. What should it be? 10a to the third. Good. B to the what? 7. Nice. Okay. Now, we've covered case C, we've covered case A, and now we're going to the last one, case B. I'm dividing. So now I'm not going to multiply the coefficients. What am I going to do? Divide the coefficients. So what's 15 divided by 5? 3. And what's c to the 8th over c to the 3rd? C to what power? What does it say I do with the exponents, everybody? Subtract them. So it's 3c to the 5th. I actually saw 1 or 2 students who added with division. That's a huge mistake. We don't want to ever do that. Okay. Let's take a look at number 7 now. What would number 7 work out to be? 21x to the 5th divided by 7x squared. What do we get? 3 what? X 3x to the 3rd. Good. Okay. Number 8. What would that be? Gabby, work with me here. What do we get on number 8? What's 12 divided by 4? 3. Now, what do I do to these exponents? Good. So 6 minus 3 is 3. That's 8 to the 3rd. And so many people put a B here on the test. Look at, well, I don't want you to lose track of where you are. A lot of people put a B. You don't. What's anything divided by itself? What's 5 divided by 5? No. 5 divided by 5? 1. What's 10 divided by 10? 1. 7 divided by 7? 1. A billion divided by a billion? 1. So b to the 4th over b to the 4th is something divided by itself. So it's just 1. When you multiply by 1, you don't change anything. Another way to look at it, though, someone said 0 before. Another way to look at it is if I subtract exponents, I get b to the 0. And what's anything to the 0 power? 1. Okay? So it's 3a to the 3rd is your only answer. There are no b's. Think of it as like if some people want to put the b's in there, it would be b to the 0. There's no b's to put there. So the answer is just 3a to the 3rd. That was a very commonly missed question on the test. Okay? And last but not least, number 9 is back to case A kind of work, where we multiply coefficients and we add exponents. -2 times -5 is 10, x to the 7. Okay? And then there were 3 more questions, 10, 11, and 12, and I really like these questions. I did not make them up. They were made up by a teacher from Oregon named Mrs. Desmond, or she either made them up or she found them somewhere. But it's really good. It kind of takes the rules and it looks at it slightly differently. Again, we're going to add exponents. Notice right away that the common base of 7 stays the same all the way through. So in other words, what does x have to be so that when this is 5, it comes out to 7 to the 10th? What does it have to be? 5, yeah, absolutely. Because if that's a 5 there, then 5 plus 5 is 10. So the answer to number 10 is 5. Then we get to number 11, and notice they get you to 27 here because 3 to the 3rd power is 27. But remember, this is the 3rd case. When I raise a power to a power, I'm going to multiply. So what number times 3 would give me 12? 4. So the answer to number 11 is 4. And number 12 is tricky. Number 12 is a really tricky question. 15c to the 5th divided by 3c to the n. Now, 15 divided by 3 is 5. That's easy. Oh, boy. Huh.
Is it supposed to be n or c?
No, it's n, that's right, but,
No, it says solve for C.
oh, okay, yeah, the n. So c to the fifth, oh, I should say, 5 minus what is 7? 5 minus what number is 7? No, 5 minus 12 is actually negative 7. Leah? Shannon?
Negative.
Not negative 12. 5 minus negative 12 is 17, but you're getting closer.
-2.
Yeah, negative 2. Now, you could do it this way. You could subtract the 5 and you get negative n equals 2 and then divide by negative 1 and that gives you negative 2. Or you could just realize that when you subtract a negative, you actually go up. Okay? So it works out to be 2. All right, so that's section 3 of the test. And now our video for that particular section is complete. And in 8th period, I'm going to try to put this all up on YouTube. So, let's see here. Escape. Finder, stop.